We are back once again, Daily LeetCode Day 85. It is a momentous day merely because it is Day 85. So we are here. We have a legendary comment from the online gamer, plus 30% tenacity, plus 30% love. Feels strong, man. Feels strong. Legendary comment. I appreciate the support, brothers and sisters. We are all daily trying to go against the grain and solve as many out and slay as many algorithm demons as we can. Yesterday was a particularly traumatic day, mostly because we were doing a problem. I said we were going to do add binary. We were doing add binary. I mentioned there was a way we could solve it in the beginning. And I said it wasn't going to work. We did it anyway. And then it turned out we were going through the problem. We spent like an hour or so fumbling through. It turned out this was not the way that we said we couldn't solve it. Was the only way that we actually could solve it. And it was optimal time as well. I think there was one more improved version, but it was negligible time. Actually, no, maybe it wasn't negligible. Let me see, actually. Oh, no, yeah, we actually got this perfect time, thinking of a different problem, but just crazy how that happens. I think some days it just be like that, especially with other things that go on. It's a daily challenge, right? But how much brain juice I have to dedicate to this is usually a function of how much brain juice other tasks of the day have taken from me. That being said, we were able to do it, and I think this is one of those cases where this problem that we're seeing here, add binary, the solution, is actually a solution for, or a component of a solution for many other medium problems. So it's just cool to see, and I think there's a value in just being able to, work through other problems, work through easies, hopefully get to where we're trying to go. So yeah, goal, I want to start blowing through these easies, but we gotta go slow so we can go fast. So that's what we're doing, right? So yeah, I think we are just working on some stuff. I've also noticed the grind has become, not the grind, but I guess the 30 minutes is non-negotiable. But the other things that I've been doing outside to kind of expand my skill set, like system design, reading the ADM, both of which we did today. And there's some cool stuff there. I'm still reading through Don Martin's System Design Primer, which is pretty dope. But yeah, it's just been interesting to see or think about. It seems that, I don't know if anyone else can relate, but it seems as my consumption goes up in terms of other things, like I would say dopaminergic activities, like, doom scrolling, YouTube, movies, long gaming sessions, anything like that. As it goes up, maybe as a function of stress or whatever, maybe any other thing, basically, then my willingness or my ability or my brain juice available for the grind decreases, which is just an interesting idea, because I think I've been reading, and I also watch stuff from Andrew Huberman. He mentioned stuff about like the mesolimbic pathways and stuff like that. As a layman myself, I only understand there's pretty much like two pathways. There's like the short-term gratification pathway and the long-term gratification. Can definitely feel like with the LeetCoding grind, I feel like I'm definitely strengthening that longer-term pathway, just because I've noticed an ability to withstand more mundanity or things that require slowing down, like, for example, reading a long contract or doing something that's particularly like just like crossing T's or dotting I's in like day to day, like maybe some detail oriented things. I'm not saying I'm good at those things now, but I think slowly they get a little bit easier. So I think we just need to keep strengthening that. But I'm noticing as my other side starts to win, my short-term side, my long-term side gets pretty weak. So it's actually pretty interesting to see. So usually we do about 2 or 3 hours a day. I think the last 3 or 4 days we've done, I think probably been closer to an hour and a half, just in total with the LeetCode, the reading, and other stuff. So I've noticed like an hour reduction, which is just strange. Not strange, but it's interesting. So I'm just trying to reverse engineer why that could be the case. It could also be external things to like work, personal stuff. But there's a part of me that thinks it's more having to do with my consumption of other things, like of other media. And I think, yeah, I think it's just easier to kind of work in a silo or a vacuum where there's a lot less, I guess, activities or things that are constantly trying to sap your energy. So I think that I'm feeling better now, and I think it's because over the last few days, I think I've been decreasing my consumption, so it's been working a little bit better. We're definitely not back to where we used to be, which is why the last few days have been like a recovery run, just because it's been quite difficult actually. So I'm definitely thinking we gotta decrease consumption, gang. And yeah, I think that's what I'm gonna go for with in the current system, and hoping that in the future, hoping maybe I'm thinking by the start of next week or the end of next week, maybe things will be a little bit normal. But yeah, I guess the way I personally control consumption is with things like screen time on iOS. So I definitely need to. As an interesting thing, I had recently purchased or I got the iPad mini to help draw problems, but it's the first device where I don't have screen time enabled. And I realized that the difficulty, which slowly crept up on me, coincides almost 1-to-1 with when I bought the iPad mini, because I didn't have any screen time on it, so I would just pretty much do a bunch of stuff and just doom scroll pretty much, and it's just hard to stop that. So I think if I had to think, I think it has something to do with that. And so I think now that I just added screen time like yesterday or the day before, now strangely I'm like, oh, I'm starting to feel a little bit better. So it's just interesting how these things work. I don't know if people can relate or not, but yeah, it's just interesting to see how consumption, or at least how my consumption seems to relate, or it seems to have a negative effect on my ability to, I guess, work on long-term goals. So that's just interesting. That being said, throwing all that garbage out the window, it is day 85, and we have 30 minutes on the clock. Make sure to join the Hyperbolic Coding Chamber. It's a chamber designed specifically for coding, a chamber designed, optimized, and maintained specifically for coding by coders. So you're going to want to make sure to join this Discord, and for a limited time today, if you join, there will be no wait time. Pretty crazy. So you're going to want to join today by clicking the link in the YouTube description below. And yeah, I also just woke up from a nap. So we're going to do 30 minutes today, and we're going to continue with the problems that we listed earlier. We spent an hour yesterday on add binary. Hopefully it doesn't take us nearly as long afterwards on these other problems, but we have remove duplicates from sorted list, same tree, and then minimum depth of binary tree to work on. So let's jump into that now. So we're given the head, interesting, of a sorted linked list. Delete all duplicates such that each element appears only once. We're given the head of a sorted linked list. Delete all duplicates such that each element appears only once. Turn the linked list sorted as well. So we have, to do our mapping of a problem statement to the example, we have a linked list which is sorted. They'd like us to remove the duplicates. Right, we have 1, 1, 2, 3, 3, and they'd like us to return 1, 2, and 3. We know that the list can also be empty. The linked list can be empty, right? And the values are going to be -1 to 100. This is guaranteed to be sorted in ascending order. So I think this problem should have a relatively simple solution. The key being that the problem given to us, the data structure given to us, has already been sorted for us. And so I think the goal would be to actually use 2 pointers. So you'd actually have a 1, like a previous pointer, which would live here, another pointer, which would live here at 1. And we can actually quickly draw over this. Right, we could have a previous pointer, which would exist here, right? And then we'd have, I guess we could call this P, right? We just call this P. right? And then we'd have another, or we just have two pointers, right? P1 and P2, right? And what we would say is if the values are the same, right, then what we want to do is just route. What we want to do is just route, let's just say P1, right, around P2 up to this version right here. That way we could do P1 equals P1.next, right? And P2 will always just be P2.next, right? And so I think that would allow us to pretty much wrap around and ignore these values. So I think let's try and implement that. So our approach is going to be 2 pointers. And the Vim key bindings are still not working, so we're just being thrown off today. But we're doing this one in Ruby today, and we're gonna try and do it the 2 pointer method to remove the sorted or the duplicate elements. So we know that the list can be empty, right? And if the list can be empty, we'll just say return head if not head, right? And then from here, we'll want to have P1, which is going to be equal to head, right? And we'll have P2 be declared dynamically, right, based on the current position. And so one way we can do this is we can say while P1 does not equal nil, right? If the current var node we're at does not equal nil, then we want to wrap around right? But what if we just have 1 and 1? We'll say P1 is not equal to nil, right? So we'd like to wrap, we'd like to set P1 equal to P1.next, which would be null. So we actually don't even need a temporary pointer, I think. And I think it's while P1 does not equal nil and P1.next does not equal nil, right? We're going to have an end here. And I think what we just want to say is P1, right? If P1.val equals P2.val, right? It means their values are the same. They're duplicates. We want to remove one. We could say P1.next is equal to, I said P2.val, but P1.next.val. And we'll say P1.next should be equal to P1.next.next. And then we'll do end, then we can say P1 is equal to P1.next. Afterwards, we could just return head or P1, it would be the same. But let's just see if this makes sense. So we have this input list here, 1, 1, 2. P1 isn't null, and P1.next isn't null. So are the values the same? They are. So we're going to set P1.next. This arrow here is now going to go around to P1.next around to 2. And then we're going to say P1 equals P1.next, right? Which means that this 1 we're now going to go to 2, which means we reach the end of the list. And P1 isn't null, 2 isn't null, but P1.next is nil. So we're now going to stop and return it. Now in this case, right, we can assume that we get to this point fine with P1 now being at 2. P1 is not nil and P2.next is not nil, right? But the values are the same, so we're just going to do P1 equals P1.next, so 2 goes to 3. 3 isn't nil, and 3's next value isn't nil, so we wrap around this 3. We say P1.next, this arrow goes to P1.next.next, which is null, and it ends the array. Ends the linked list. So I think this should work. Syntax error, unexpected local variable or method. Oops, I didn't say and. If and and P1. So I think this makes sense. Oh, we didn't check multiple duplicates in a row. So that was actually bad. So now here we have 1. Right, so we're wrapping it around 1, but we're incrementing, but we can't increment yet, right? Because if we do, then we end up skipping a value. So one way to fix this is to only increment or move to the next pointer when the values aren't the same, right? Because we wrap it around, right? And then we move to the next value. So what we can do is we can say, the Vim binding's not working, is crazy. Oh no, I think I have it off. Let's see if they even work today, actually. Okay, Escape doesn't work still, so I think I just need to reset my computer. But we'll have else if, right? Or actually we'll just have else, right? If the values are the same, right, then we want to wrap it around, right? And then, right, now if they aren't the same, then we want to move to the next value. So I think we should still get correct for this one, except now when we put in 1, 1, 1, we should be good. Let me check if there's any more things that could happen. It's already sorted, so we should be good. So this seems to work. I'm not certain why this is so slow, because I don't think you can, this is just linear time. Maybe there's something faster you can do. Okay, so that is good enough, right? Let's try same tree. Given the roots of 2 binary trees, P and Q, write a function to check if they are the same or not. Given the roots of 2 binary trees, P and Q, write a function to check if they are the same or not. 2 binary trees are considered the same if they are structurally identical and the nodes have the same value. I think the follow-up is they're gonna ask for iterative. Oh, they didn't ask for it. So if 2 trees are exactly the same, these 2 trees are mirrors of each other. Now 2 trees are exactly the same. They're structurally identical and the nodes have the same value. I was gonna say you could do a BFS and then compare the output, but this actually wouldn't make sure the trees are the same. Because imagine if we had one more tree here. Actually, there's no point in copying it, but imagine if we had 2 trees here, right? And then we have these 2 trees. Imagine if we had one more extending out here, one more node that says 5 or 4. And in this one, we had one that said 4. If we did a BFS, we'd output the same values here, right? Only if we didn't include the null values. But if we didn't include the null values, they would look like 2 separate trees. So I think what you can use is pre-order or in order, because I'm pretty sure in order traversal of a tree is not unique, but pre-order traversal of a tree and post-order are unique. So I think if we did a post-order traversal, actually, I think we could just compare them, right? We could just say, I don't want to simplify this too much, but if we say P, right, we have access to val, left, and right. If we say P, I think we could do this with recursion and do it as a string of comparing a logical construction or a logical sequence of Boolean operators. So what if we did something like return P and Q and P.val equals Q.val, and then we would also pass in the same function again is same tree, except we do P.left and Q.left and is same tree Q.left. I mean P.right and Q.right. And I think this should work, except the final case, or I guess our base case might need to be, or one case we might need to consider is that if not P, right, and not Q, if they both don't exist, right, we could say return true if not P and not Q. That way, if we ever get to the end, right, where there are two subtrees might be empty, we'll stop and we won't continue propagating. But let's see if this makes sense. If we call is same tree with P and Q, we won't return true because both of them exist. Then we're going to say, okay, do P and Q exist? They do. Are the values the same? Yes. Okay, now we're going to push a call of is same tree on the stack. Do P.left and Q.left, right? They both exist. Are the values the same? Yes, because 2 is equal to 2. And then we'll do is same tree for left, right? They're both null, so we return true. And is same tree for right, they're both null, so we return true. So we know the left trees are the same. Then we'd come back out to our original call up here with 1. And then we do the same for the right subtree. Values are the same. And they both exist, and both of their subchildren don't exist. Now if we do something like this for 1 and 1, P and Q both exist. Their values are the same. But now we're going to check if the trees are the same for P sub left and Q sub left, and we can see that P, not P, right, if we look at the left, right, they both don't exist, which actually is a problem. So we have actually false here, which would stop our propagation. So we'd return false. So I think this should work. Oh. Oops. Oh no, I was trying to look at where my submission was. So we have 1, 2. So when we have 1, 2 with no children, wait, where'd my code go? There we go. If we have 1 and 2, and then 1 null 2, I'm not exactly understanding what the difference is here. We have 1, 2 presumably looks like this, and 1 null 2. These trees would be completely different. I'm not understanding why we're returning true. So we would do P and Q. They both exist. The values are the same. And then we're going to say, okay, is this the same tree? If we do P.left and Q.left, we go 1 and 2. We'd have 2 and null, right? And then we say, okay, this P, right, which is 2 and Q exists. No. Does P.val equal Q.val? Oh no, I think I'm doing something. No, wait. Might be a misunderstanding of how variables work, I guess. I'm not understanding that. It should kind of stop there, I think. Because at the end we'd return a logical, like, concatenation of expressions, and if there's one false, the whole thing should be false. this might be strange. I'm going to put P, and then I'm going to put Q, and then we're going to try the version that failed. I think we want something more like, oh, we can't even move up and down. I'm so confused as to why I have to click. Right, even here it shows that it doesn't exactly work, right? Because we have 1 and 1, which we compare, and then we'd go on to compare 2 and 1, right? Where q.val doesn't actually exist. So if we do p and q, we should return false here. But we were getting, our output was null. Oh. Yeah, I think this is some Ruby specific stuff that we're just messing up here, because I think we're just not actually returning anything. I'm actually confused. I'm sure this works in JavaScript, but I'm not exactly certain. What if we do, I'm going to do puts p and q. Maybe that's just a strange thing to say in Ruby. Oh, the code, the lines are being strange again. Maybe we should just be more explicit. P does not equal nil. We still can't move cursor. P does not equal nil. And Q does not equal nil. So I guess P and Q, I think they mentioned this in the course I guess this specific section of memory, even though it says nil, still exists. Whereas in JavaScript, you receive a reference to it and it wouldn't exist at all. So I think, yeah, it looks like we got caught by, I would say we technically solved this problem in 2 minutes, but we got caught by some Ruby idiosyncrasies. Interesting. I would say right, so I would say this runs in the height, because this is really a depth first search. I would say this probably runs in the height of the shortest tree. So if we have 2 trees of different heights, we'd find the first instance, right, even if we had an arbitrarily large tree, the first time we'd notice that the trees aren't the same. If we assume that they were the same up to a certain point, it would be the length of this, or the height of the shortest tree, because it's depth first. And then it would, worst case though, I think it would be linear time. N is the number of nodes in the tree, because you'd visit all the nodes in the tree with linear space as well. Cool. Okay. I think we had minimum depth of binary tree. I remember Pascal's triangle is a good problem, by the way. So given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path. Minimum depth is the number of nodes along the shortest path from the root node down to the nearest, Find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Leaf node is a node. So would this be 1? It says 2. Minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Leaf node is a node with no children. I guess it would be here because it would be 2. The number of nodes in the tree is in the range 0 to 10 to the 5th. I want to say you could do this with it. I think you could do this with a DFS, and I think that might be the only way to do it. Not the only way, but I think you could do this with a breadth first search, because we do 3, then 9, and 20, and then for each node we can just check if it has no children, right? And that would give us the shortest path. The problem is, for a tree that is quite large, this would actually pose a problem, a memory problem. But let's try it anyway. Let's try it anyway. We know there can be nodes in the tree. So we'll say return 0, right, if root equals nil, right? And then we can do, and our queue is going to be even slower because you don't even have access to a native implementation of a deck or a linked list. But we'll try it anyway. And the goal would just be to do a breadth first search with the queue, and then we could just keep track of our path, right, within the queue. So what that would look like is we'd have a queue, right, and we'd have our root node, right, except instead of it being by itself, we'd have a tuple with it, which would denote the length of the path so far, which would be 1. And then for our queue, we'll say, well, queue.length does not equal 0. I'm going to say end, and then we're going to say, I guess presumably maybe there's always a node with no children in the tree. It doesn't say. So let's assume, right, if we can't find a node with any children, we'll return -1. But to start, we'll say the current node, which will be equal to queue.shift. And this will eventually give us, I think, n squared time when we pull off an element off the queue. And I'll make this bigger since we're not really writing a lot of code here. And then we could say if cur, actually we want to do cur and path, right? We'll say if cur.left equals nil, and cur, we can actually do it like this, return path if cur.left equals nil and cur.right equals nil. Otherwise, right, we'll push 2 new elements onto the queue, or 2 new tuples. It's going to be cur.left with path plus 1 and cur.right with path plus 1. And if we move this over a little bit, I think this should work. So for example, we'll start with 3 in the root, in the queue, right? 3 with path of 1. The queue won't be empty, so we're going to pull 3 off of the queue, destructure it into current path. Right now we're going to check, does 3 not have any children? It does, so we're not going to return anything. We're going to push 9 and 20 tuples onto the queue. Now we're going to check 9, which has a path plus 1 of 2. We're going to destructure it 2, right? It's going to be the node, right, itself 9 with a path of 2. We're going to say return 2 if cur.left equals nil. It does, and cur.right also equals nil. Need more trees to test. This works if the root is the only node in the tree. And I'm also realizing we also want to make sure, right, that if we only want to push these values onto our tree if they actually exist. So if cur.left is not equal nil, we can do actually something smaller or simpler like this. We'll say q.push. Maybe it's just easier to read if you just say if cur.left does not equal nil. And then you can just duplicate it. Then we'd have if cur.right does not equal nil, and we'll push it on with path plus 1. Can we generate any trees where this wouldn't work? I think this should be good. Syntax error, unexpected end, expecting slash. Oh, we're missing the closing parenthesis for both of these lines. So it works with the first case. Okay, so this seems to be very, very slow, which I think we knew with the depth, with the BFS. It takes up there's no way this algorithm takes up 200 megabytes of memory, unless this is actually true for Ruby. But there's no way that this is true. If it is, Ruby is actually crazy. This may not, okay, yeah. I thought Ruby was the greatest language ever. Okay, 200 megabytes is actually crazy. So maybe we'll try. I want to see how much better it would be if it was a DFS. We definitely use, would we use less memory? Not in the worst case, I think. In the worst case, we still have to search the entire binary tree, no matter if it's DFS or BFS. Yeah, in the worst case, you still have to do both. But maybe the average, yeah, I think it would be the same. What if we just ran it one more time? This is a little better. There's just no way. I don't see how you could do this faster with DFS. If it was a binary search tree, we could, no, actually that it wouldn't change anything because we're looking for leaf nodes. Yeah, this one, I don't think DFS would change much. It said linear time and linear space. So yeah, it looks like that seems to be the case. I would say that's a good wrap. We did I think about 4 problems, or three, maybe 4 or 2 or 3, but see, that's a wrap for day 85.